Okay, so for Q6, question 6, it is about EM spectrum. So I will use this chance to revise with you some of the key property as well. So nonetheless, you need to know the sequence. So it is gorilla X urinate violently in my room. So if you do not know, V is your visible light, I is your infrared, M is your microwave, and of course G is your gamma ray. So all these things I'm not going to spell it out in my video, you're going to figure out. But after I teach all this, right, gorilla X urinate violently in my room, right, a lot of you didn't memorize why gorilla first. So please remember that gorilla is in this position because it has the highest frequency. I shouldn't use the word max. It is just high. And to this tail end, it is low frequency. Now, because for EM spectrum, the wave will travel at same speed, constant speed. This V you need to know, it is 3 times 10 to the power of 8 meter per second. This is in air or vacuum only. This means that if you are having all these wave and you send it in glass, all the 7 wave will travel at different speed. Okay, so this statement here is very important, in air or vacuum only. So if, for example, you go and use X-ray versus maybe radio wave, and you send both wave into a piece of glass, okay, then the speed of X-ray and radio wave will be different. Okay, it will be different. They will slow down by different amount. So that's number one. By extension of this, because when we say speed of all the EM wave is the same in air and vacuum, if you look at the formula, V equals to F lambda, if this guy is kept constant, right, and if you have a F that is very huge, then by extension this guy must be a small number. And if you look at the other end, if frequency is rather small, then that means the wavelength must be high. Okay, for those who are weaker in mathematics, this is what I mean. If let's say 4 is the speed, then if my frequency is very high, what value can I have for my wavelength? 1, no? Right? And if my frequency is very low and it has a value of 1, this means that my wavelength must take up a bigger number. So actually what this means is that when gamma is having a high frequency, it also means that it has a very low wavelength. And by extension of that logic, radio wave will have the longest wavelength. Okay, some other properties that you need to know is that gamma wave is the most energetic wave. Okay, that's why it is used to treat cancer cell, because it is so energetic, it will kill off the cancer cell. And you should know that of course these are the safer, this is considered the safer waves because it has a low frequency, so it is rather safe for human. So because of that, we use these 3 waves for communication. Infrared can be used as communication. It communicates between remote control to your TV. Microwave, we also use it for communication. So this one is more for satellite communication. Satellite. I suddenly forget how to spell satellite, but you get what I mean. And then this one is for local broadcasting. And you need to know why. You need to know why radio wave is used for local broadcasting, because down here, right, it has longer wavelength, and when the wave has longer wavelength, right, you need to take my words first lah, because at your current syllabus you are unable to explain this particular phenomenon. When the wave is of a longer wavelength, it can actually bend around obstacle. Okay, so for example, if you have a local station and you want to broadcast this wave, right, and then you have HDB standing in your way, if you are a person listening to the radio here, normally you won't be able to get the wave. But because radio wave has long wavelength, right, the wave can actually bend around the building and reach you. So similarly, like your home Wi-Fi or the school Wi-Fi, you can even get it in the toilet because the wave can bend around and reach you. Okay, but for example, if you are using a microwave, for microwave it is slightly higher frequency, right? So a property of high frequency wave is that it is very directional, and it can actually penetrate most of the stuff like your atmosphere. So for example, if you are on Earth, right, and then in outer space there is this satellite that is zooming past along the orbit, right? It is zooming past along the orbit. So on Earth you need to have a satellite, and you need to point directly at the satellite, and the satellite will move, right? So as the satellite move, your satellite dish must point at the right direction and send the signal accordingly. So because of that, the wave must be very directional, if not it will spread out. So when wave are more directional, you should I mean, if your purpose is more directional, then you should use a higher frequency one, and you should use satellite. Then you may ask me, teacher, then why not you push it to the extreme and use gamma ray lah? Can lah, you can use gamma ray, but because gamma ray is very energetic, so you need to use a lot of energy to make it. So it will be very expensive in a way. Uh, in another reason is because gamma ray is very powerful. So for example, if you have a satellite dish and unfortunately it's next to your HDB, I think you do not want to live there. Okay, because that gamma ray, while it is very directional and it points to the satellite, right, some of it may come out, you know. I'm not saying that it will be 100% directional, maybe even 80% directional, the other 20% will penetrate your cell and then cause the cell to mutate and you will get cancer. Okay, so these are some of the things you need to know about EM wave. And down here is all the purpose. X stands for X-ray, U, so on and so forth. Okay, you go and read about it. Yeah, this one I'm not going to spend time talking about this.